One of them. Let's do 2. 2's the harder one. How do you feel about 3?
I nominate
3, don't like it.
Wait, what's this
think
for?
we should do 4.
This is the test review. Okay.
no.
Okay, I understand what you're saying. Number 5.
What's my role if I get 100 tests?
I will send it home to your parents along with the other exams that you did well on and tell them to buy you ice cream this weekend. I have them all scanned. I just need to get them in the individual emails. It takes forever.
Go get me
Oh, I
ice cream.
forget to send you my email. Should I do that?
Any others? No one wants to see 7 or 8?
Relevant.
Guys, pro tip. Not saying I did this because I don't remember. I made this last night, the actual test, right? I'm betting if I were to remove any of them, I'd remove these guys, right? There's other ways I can test this. For instance, if you don't know how to name an angle, you're not going to know how to do this one, right? If I ask you what angle DAE is, you're going to be like, what's that,
That's light work.
right? So I can already test that somewhere else, so I probably will remove those guys.
No, we need that one.
Nope, sorry. Waste your time. Number 10?
As well.
All right, so 10. Okay, we can talk about these. All right, so basically what I assumed we would do. Okay, it's gonna be quick. My advice to you is don't write this stuff down, screenshot it. Okay, that way you can watch the magic happening in real time, or if you'd rather write it down and then watch the video at home, just make sure you can see the magic happening, okay? What happens now is what you need to know. We're talking concepts here. Trust me on the numbers, okay? Here's the idea. So, find CD. First of all, we should probably pay attention to that. We need to find this.
Your mic keeps cutting out. I can't find the line.
The mic is cutting out? You can't find the
It's
ledge?
like going red. Just
That
wait.
means you keep going.
Hey.
No, we're good.
It, of course.
Wait, you mean it's going red on there?
Ah, there we go.
Oh my
Why
god.
do you talk right into the mic?
Because it's red on there. Okay, so here's what we're gonna do. I'm gonna back up just a little bit, okay?
Go.
Actually, you know what? We'll,
Give us a nice loud A.
we're clipping. Yeah, we are clipping. So what that means is that the sound wave itself is too big. And what happens with the sound wave, let me talk about it real quick. So sound waves, as far as you're aware, okay, a really simplified version, looks like this, right? And so there's only so much headroom that a piece of like data can contain. And so when that gets too big, maybe the headroom's here, see how it cuts it off? And so what happens is it flattens it out right there, and that's a really unpleasant sound, okay? That's what we call clipping, because it clips the top of it. So you have to make sure that you don't go red, because there's only so much that set of data can
If
contain.
you're watching the stream,
Yeah.
add my
Worst third-hour stream ever. All right, so here we go. The idea here is we're going to take these two guys and add them up.
No.
This plus this.
No.
These two added together should get us the whole thing except what? What part did we count twice if we add those two up? We counted the middle twice. See how this counts the middle? And see how this also counts the middle? So we have to subtract one of the middles, right? So x plus 7 plus 11x minus 2 minus one of the middle parts is going to get us the whole thing. And the whole thing is 13x minus 3. Do you see the setup? Because that's the key. Then we get our x's together and we do algebra, right? I'm going to do that real quick. We've got 12x's over here. We've got, oh no, we have more than 12x's because we subtract 3. We have 9x's over here. And we have 5. And then 13 minus 3 over here. Terrible idea in real life, great idea in math. I'm going to get my x's together by moving this over. And I'm going to subtract or add 3 to this side. I get 8 equals 4x. And then I divide by 4 and I get x equals 2. Now, great, x equals 2, but they wanted to find CD, right? So what we need to do is think, what is CD as an expression? We need something with x in it so we can plug it in and get it, right? So notice, this whole thing is BD, right? 11x minus 2. What can I subtract from that to bring it down to CD's size?
3x.
3x, right? I can subtract that bit. So whatever this is 11x minus 2 minus 3x. The whole thing minus this bit gets us this bit. So 11x minus 3 is 8x, so we have 8x minus 2. What is x for this problem?
2.
2, right? So if x is 2, we have 16 minus 2, which is 14. So CD is 14. Again, we did this in class, right? But try doing it on your own at home if you need more examples. There's also number 1, okay? Yeah. Yeah, go.
Just not in here.
Screenshot it if you need it.
Just not in here.
Yeah.
What if I just took a picture with you in it?
I don't know, like, what if we were all living on the ceiling and not the floor? What if north was south?
Then north is the south.
Is it fun to pretend you're in middle school all the time?
South.
Because that's like the most middle school thing you can do is be like, what if this? like what if? Like no one cares. All right, Pythagorean theorem. Bye, Danny. Let's call this x1, y1. This point. Are these two dots the same horizontally, or are they different horizontally? Are they in the same location horizontally? If I start here and move to the right, I've gone somewhere else horizontally, right? So they are different horizontally. So that's x1, that's x2. Are they different vertically? Meaning, are they on the same floor, right? If we think of it as an elevator, are they in the same floor? Yeah, they're in the same floor. So they have the same y value. You dig?
Yes.
Now this guy, again, comparing it to our first dot. I always go with the far left as my first dot.
We can't see the top.
Can't see the top. All right. How about now?
Yep.
Okay, wonderful. So these guys, how are they different? Are they different vertically or horizontally? Yeah, Zed.
Vertically.
They're different vertically, right? One's on the top floor, one's on the bottom. So different. That's y2, that's y1. They're the same horizontally, right? So that's x1. You need to label those points. It says start with the Pythagorean theorem. What is the Pythagorean theorem? A squared, b squared, c squared with an add sign and an equal sign in between them. Now, we need to substitute something for a and b to work our way towards the distance formula. So here's what we need. We need to know what a equals, and we need to know what b equals so we can substitute them, right? Well, check it out. We are not going to get a number for a or a number for b in this because we don't have any numbers. We just have letters. B is the distance in this one vertically. You guys aren't used to that, are you? We're used to A being the bottom part. I switched it up. It's okay. We can do that. A is going to be the distance vertically. Well, what is distance? What is distance? Come on! Distance is? Subtraction. Thank you. So to find the distance, how long A is, we have to subtract the values, right? What's x1 minus x1? Nothing. So it goes away. What's y2 minus y1? It's y2 minus y1, right? We don't know. But that's what it is. Now for b, b is the horizontal distance, right? So we subtract the x's and we get something. We get x2 minus x1. If we subtract the y's, we get nothing. So there's a, there's b. Danny. Throw.
Ready?
Yeah, I'm ready. Thank you. All right. So now that we have this, we need to tell y. Y is a y2 minus y1. Horizontal distance. Distance is subtraction. That explains the minus sign. Horizontal, I'm sorry, not horizontal, vertical. Vertical explains the y values. Sorry, I'm used to writing horizontal for a. I switched it up just to screw with you. So now we've got horizontal to make you think, right? Not just memorization. And this is horizontal distance because it's the x's, right? And subtraction is distance. Now that we know this, we can say that, well, if a is y2 minus y1, can I switch it out? Yeah, we can switch it out. So something squared, something else squared equals c squared. Of course, there's a plus sign in the middle because it's a squared plus b squared, right? So what am I switching out? Well, instead of writing a, I'm going to write what for this diagram? What am I going to write instead of a? y2 minus y1, because in this one, a is the vertical value, right? And b, we're going to switch out x2 minus x1. Then we have our last step, which is to root everything, right? There we are. It says, how would things change if A and B were switched? I'm not going to ask you that on the exam. I just want you to think about it, right? If A and B were switched, well, then A would be the horizontal value, which means instead of subtracting the y's, we would subtract the x's, right? And B would be here, which means it's the vertical value, which means we subtract the y's, right? Something like that. Words are hard. Questions, comments, concerns? This can be one of the easiest ones on there, and it's worth so many points. Or it could be the hardest one, right? You need Pythag. That should be free. The points, know how to find them. Distance formula by now should be free because you probably have it memorized, if anything. You just got to tell me this middle part, okay? That's the hard part. Middle part here, points there. All right, we're skipping number 4. You said do number 5. Number 5 asks you to do distance formula and section formula. We're not going to do the distance formula right now because we don't have time. We can do distance formula later on that last problem, the weird star-looking thing, okay? It's the same idea. So let's just do section formula. Section formula says we need m and n for a ratio. What's our m in this problem, Danny?
Our m?
Yep.
Hang on.
5, very good.
No, 2.
5 is correct.
2 is
N, very good. So we have a 5 to 2 ratio because we're talking 5/7 versus 2/7, right? Altogether it should be 7/7. 5 comes from here. The 2 comes from here. See how 5/7 and 2/7 complete each other to make 7/7? Okay. So if I had a ratio, or if I had a fraction of, I don't know, how about 3/5? Right, if that's what they gave us, what would my ratio be for this? 3 to 2, right? That's how you find the ratio. It's not 5 versus 7. It's not 3 versus 5. It's 3 versus 2. That's 5 versus 2. If I had 7 out of 11, it'd be 7 versus 4, right? Okay, so that's our M and an N. So remember, section formula is just the same thing as midpoint. It's the idea of the average of the x's, average of the y's, right? So we're going to add them up, and we're going to divide by the number of pieces. Now, how many pieces are we going to have total here? We're going to have 7 total pieces, right? So we're going to divide by 7. And where's that 7 pieces coming from? Well, we're going to have 5 of one of our x's, and we're going to have 2 of the other x. So 7 total pieces, right? We're going to have 5 of one of our y's and 2 of our other y. Now, section formula is particular. You can't just do whichever x first. Which x has to come first, x1 or x2? x2 has to. It's misleading, isn't it? It's because when we cut up into sections, we're talking about not a halfway point necessarily, right? So the question is, do you want something that's 5/7 of the way close to B or 5/7 of the way close to A, right? That's 2 different coordinates. So if we want it starting at A and going to B, we have to put x2 first. Now what's our x2 first here? 1. So the 1 comes first and then the -6. Remember, we're averaging the x's here, not the x and the y, but our x's. And then we're going to average our y values. Which y value comes first here? -8, y number 2, right? And then we have y number 1. If you do it that way, it'll work out nicely. 5 times 1 is 5. 2 times -6 is -12, and that's over 7. Then we have 5 times -8, which is -40. 2 times -1 is -2. So when we put those together, we get 5 minus 12, which is -7 over 7. And then -4 minus 2 is -42 over 7. And those should be some divisions that you know. -7 divided by 7 is -1. -42 divided by 7 is -6. So that's our point. The key to remember is that it's M and N. How to find them, okay? And then thinking about x2 and y2 come first, right? x2, x1, y2, y1. Plot your points. -6, -1, 1. Let's screw it up a little bit. 1, 2, 3, 4, 5, 6. -1, that's A. And then we have 1, -8 for B. 1, 2, 3, 4, 5, 6, 7, 8. Always label your points. And then we're going to connect them. What happened? We're here. -1, -6 is our point. Right here. Point P. See how it's closer to B than A? If you had flipped your X's and Y's, right? If you did, I'm sorry, if you flipped your X1 and X2, if you'd done X1 first, you would have got the point that's closer to A. Okay? So 5/7 going from B towards A instead of going from A to B. Questions on that? Could you do distance formula? Yeah, you could do it real quick if you wanted to. Bam, bam, right? Plug them in, write them down. This one, midpoint. We're on page 5, number 6. Sorry. Endpoint, number 1, is -3, -2. Now, normally we take our 2 endpoints and we plug them in and get the midpoint, right? That's the formula. You take your 2 endpoints, you average them, that's the midpoint. But we don't know the second endpoint. So it's some x, some y. Now we know the point in the middle. The midpoint is 1 5/2. So midpoint formula says take to find the midpoint, you average your endpoints, right? x2 plus x1, y2 plus y1, and then divide by 2, right? That's midpoint formula. Now we know what M is. What is M? What is M? They give you it. What's the midpoint? They give you the midpoint. 1, comma 5 halves. And that's going to equal the average of our x's. Well, we only know one of our x's, right? The negative 3. That's x1. So we have x, the one we don't know, plus x1. Where am I getting that x from? Here. And our x1 in this case, we know what that is. It's negative 3. Now, if we don't know that y, so we just write it down as y. But we do know this y. What's this y? Minus 2. So let me break that down again. We know the midpoint. We know one of our x values and one of our y values, but we don't know the other ones, right? That's what we're looking for. We're trying to look for that mystery endpoint. The idea here is that they give you an endpoint and a midpoint, and they say, where's that other endpoint going to be? Normally, we take the two endpoints and we find the midpoint, right? But we already know the midpoint, so it goes here. So now what does this mean? Well, check it out. This part is the x value of our midpoint, right? Well, there's the x value of our midpoint, so they should be equal. This guy's the y value of our midpoint. That's the y value of our midpoint, so they should be equal. So set them up, knock them down. We know that 1 should equal x minus 3 over 2. I got that from the yellows, right? From the green part, I know that 5 halves should equal y minus 2 over 2. Right? Those guys are equal, those guys are equal. So now we just do math. We times by 2 to both sides over here, and we get 2 equals x minus 3. Then we add 3, therefore x is 5. I encourage you to go back and watch this in slow-mo. Times by 2, well, 5 divided by 2 times 2, what's that? If you divide something by 2 and times it by 2, you get the original number, right? 5 divided by 2 times 2 is just 5. Then we add 2, therefore y equals 7. So our answer for our endpoint that we're looking for is going to be 5 comma 7. That will be on there. It will, guaranteed. So again, the setup. Plug in one of your endpoints. Plug in the other one is x and y because you don't know what it is. Plug in your midpoint. That part should equal that part. That part should equal that part. Knock them down. Next page. They tell you that angle CAF is 85. CAF is this angle. So that whole thing right there is 85. So let's go find out what x is. We know that 35 plus 2x plus 40 should equal 85. You smell what I'm stepping in here? That guy plus this guy plus this guy should add up to 85, right? So I subtract the 70 that's here, 75 that's here, and I get 2x equals 10. Divide by 2, x equals 5. So if x is 5, what's angle DAE? It's 10. BAD, that's this angle. Well, we need to add these two up to find it, right? Well, luckily we know what x is. X is 5. So what's 4 times 5? 20. So BAD, since we know x is 5, is going to be 20 plus 35, which is 55. Shrifty-5. How would you find FAB? Yeah, Catherine.
85 plus 20.
Yeah, that's 85 plus the 20 we just had, so 105. If we extend Ray backwards, hi Ray. Call it G. How can we find this angle?
180.
Well, the whole thing's 180, right?
So subtract it.
Subtract 105, right? What do we get? 75. You zoom out a little bit. Number 13, the last one you wanted to see. Let's see if we can do it. First of all, convex or concave?
Cave.
How do you know it's concave?
Because it caves in.
Speak to me mathematically. How do we know it caves in?
Because you can continue the line it intercepts.
Cheyenne made eye contact with me. Do you have something to say?
Two of those are measured at
Yeah, so check it out. We have a reflex angle right here. 2 of them. Concave, how many sides? 8 sides, octagon.
So if it has to reflex angle, it's concave.
Internal reflex angles are concave, yes. Internal ones. Okay?
You're probably going to ask that on the quiz.
You don't need to know it. Find the sides using distance formula or Pythag. If you need to see this example, we did do it first hour. I probably won't post this video because it was cut up. Sorry. Although, nice. Yeah, I saw it had 6 views, and it was like I just posted it.
I was in Mr. Bartow's.
Gotcha. Shout out to Bartos.